All right, so this is a continuation of 5.3. It's the very end of it, okay? And it is when we reverse what we were doing yesterday. So yesterday, I would have asked you to find like the cosine of 30 degrees or a reference angle of 30 degrees, like a 210 or a 150. You would have set up your triangle, you would have filled in your side lengths, and then you would have found the adjacent and the hypotenuse. With these questions, we are reversing that order. So the directions would say find theta over the interval of 0 to 360. Notice there's a bracket on 0 and a parentheses on 360. That means if 0 is an answer, we include it, but 360 we do not. So we change it to say cosine of theta equals square root 3 over 2. So what we're going to do is ignore the sign for now. We're going to come back to that in a minute. But we're going to set up a triangle. We're going to put theta in the corner. Cosine is the ratio of the adjacent side to the hypotenuse. So I'm going to make the adjacent side the square root 3. And I'm going to make the hypotenuse 2. Because it's adjacent over hypotenuse.
How do you know which corner it is?
It doesn't matter.
Okay.
It doesn't matter. As long as you put the root 3 adjacent to it. So if you think about your 2, there's only going to be 2 triangles that we can use here, which are our special triangles. The 2 triangles that are the 30, 60, 90 or the 45, 45, 90 triangle are the ones we're going to use. And in those, it is 1, 1, and root 2, and 1, root 3, and 2. So when we set up the triangle that's there, you can complete the other side. I would know that this is a 1 because that's the combination. It would be root 2, root 3, and 1. But the goal is, God bless you, the goal is to figure out which angle would go there. So which value of an angle would go where the theta is. And if we look at my triangle, which angle is adjacent to root 3? The 30 is the adjacent to the root 3. Opposite the 30 would be the 1, adjacent to the root 3 would be the root 2, and then the hypotenuse would be 2. So now we have the value for theta if it was a positive root 3 over 2, which means that is my reference angle. If it was positive root 3, I'm almost done, but it's not, okay? Which means I now need to think about my all students take calculus and figure out which quadrant gives me a negative cosine. Which quadrant gives you a negative cosine? So that's second quadrant and third quadrant. So now I have to use my 30 degrees in the reverse way. Normally we would do 180 and we would subtract the angle from it to get 30 degrees. Now we're going to take 180 and we're going to subtract 30 from it to get the angle that would give me a 30, 60 degree, 90 triangle in the second quadrant. So one of the answers here is 150 degrees.
It's T.
What?
Is it T? Tangent?
Is what T?
The angle we need.
No, the angle is 150. So theta is 150. And then the second angle is in the third quadrant. So I'm going to take the 180 and I'm going to add the 30 to it. And I get 210. And that's the other angle. So at those 2 angles, I would have a cosine of negative root 3 over 2. Yep.
Where did you get 180?
That's the x-axis. So if I'm using a reference angle, I use it from 180 on the left side.
So there's 2 answers?
So most of these will have 2 answers. Yep, not all of them, but most of them will have 2 answers.
And do you put it in parentheses?
You just list it. 150 degrees, comma, 210 degrees. Yep. So now if I go back to what it had said originally, cosine of theta equals negative root 2 over 2. This is where it gets a little bit trickier because there is no triangle that has root 2 and 2 in those locations. Where is root 2 normally? It's on the hypotenuse. So how did it become different? It's rationalized. So this is really 1 over root 2 rationalized. Do you see that? So we use those values. So if the root 2 is in the numerator, it was rationalized, and you have to switch it. So now cosine would be 1. Hypotenuse would be root 2. Missing side would be 1. Which triangle is this? 45, 45, 90. Does it matter if this is 45 or this is 45? No, they're both the same. So theta here, if it was a positive root 2 over 2, would be 45 degrees. That's going to be my reference angle. And we just said cosine is negative in what 2 quadrants? Second and third. So I take the 180, I subtract the 45 from it. I get 135. That's one of my answers. And then I take the 180, I add the 45 to it. I get 225. And that's the other angle.
How does he not to add 180?
Because it's in the second and third quadrant. So in the second quadrant, we subtract it from 180. In the third quadrant, we add it to 180. All right, so we're going to do a bunch more. This would be the same set of instructions from 0 to 360. So there could be more than one answer. I'm going to draw just one of each triangle because we're going to use both. This would be 1, root 3 and 2, and then the 45, 45, 90. 1, 1, and root 2. So most of them, just by looking at them, you can at least narrow down if it's the 45 or the 90, or the 30, 60, 90, because if it has a root 2, it's going to be a 45. And if it has a root 3, it's going to be a 30, 60, 90. So if I look, every single one here has a root 3, which means I'm not going to use this triangle at all this time. Does that make sense? If it had a root 2 in it, now I would know to pick the 45, 45, but none of these do. So we did this one already. That's the first one we did, the negative root 3. Actually, but let's pick sine because there's none on here that say sine. So let's change that to sine. So if it's sine, I'm looking for the side opposite the angle to be root 3, right? Which angle has a side opposite it, root 3? 60 degrees. So that's my reference angle. But this is a negative. So if all students take calculus, which quadrants am I looking for sine to be negative? Third and fourth. So in the third quadrant, I do 180 plus 360. Plus 60. And I get 240. And in the fourth quadrant, I'm going to do 360 minus the angle. And I get 300. So those are the two angles that would give me a sine of negative root 3 over 2. On this, oh, sorry, what?
We never used 90 or 270.
Nope. Only if it gave you if it was like a cosine of 1 or a cosine of 0 or sine of 1 or sine of 0, those are going to be your quadrant angles. Because it would be at the top, right? Like if it said cosine theta equals 1, that happens over here. So that would be 0 degrees. Does that make sense? Because the cosine's your x. So if a cosine or sine, if my question says cosine or sine is 0, 1, or negative 1, I have to use the quadrant angles. I can't use a triangle. That won't happen now.
How did you get 60 for the theta?
Because sine is opposite over hypotenuse. So I went to my 30, 60, 90 triangle and I said, what angle is opposite root 3?
Oh, 60.
Yep.
How did you get the blue 360?
The blue 3, you mean the 300 or the 360?
The 300.
If it's in the fourth quadrant, we have to do 360 minus the reference angle.
Would we just keep it if it was in the first
Yep.
quadrant?
And you'd have to find, it's going to be 2 ways though. It's going to be 2 spots. So when you get to 18, that's going to happen. All right, so look at 16. 16 says tangent is negative root 3. So tangent would be opposite over adjacent. Technically, there's a 1 in the bottom there. Which angle has a side that's opposite root 3 and adjacent 1? 60 degrees. So again, my reference angle is 60 degrees. But now I need to know where tangent is negative. which happens where? Second and fourth. So in the second, I would do 180 minus 60, and I'd get 20. That's one of my answers. And then in the fourth quadrant, I do 360 minus 60, and I get 300.
It's 120, right?
Oh, 120, sorry, yes, 120. And then it's 300.
When do you add 60?
You add it if it's in the third quadrant. So first quadrant, it is what it is, right? Theta and theta prime are the same. In the second quadrant, when you're finding the angle, so it's the reverse angle. Now we're finding the angle. We would do 180 minus the reference angle. In the third quadrant, we do 180 plus the reference angle. And in the third quadrant, we do 360 minus the reference angle. Yep.
We get twice enough if we don't put the degrees on.
Probably if this is on, it's going to be on the multiple choice part, so it wouldn't matter. Yeah. Sure. All right, now go to 17. This is cosecant, which means it's the reciprocal, yes? What would it be if it's reciprocal? Sine, and it would be flipped, right? 3 over 2 root 3. Is there such a ratio? So what happened here? It was also rationalized. If I re-rationalize this, I get 3 root 3 over, this becomes 3, 6, or root 3 over 2. And it's plus and minus, which means this is going to happen 4 times because it's in every quadrant. So where is sine root 3 over 2? What angle's opposite root 3? 60 degrees again. So I do 1 time for 60 degrees in the first quadrant because it's all 4 if it's plus and minus. I would do 180 minus 60 for the second quadrant. That's 120. I would do 180 plus 60 in the third quadrant. That's 240. And I would do 360 minus 60 in the fourth quadrant. And that's 300.
Can we just put it in that order?
Yeah, I mean, it doesn't really have to go in that order, but if it said to put it in order of least to greatest, it would be in that order. All right, last one. Tangent, root 3 over 3. Root 3 and 3 are not side lengths, which means this was rationalized, right? Root 3 is a side length, but not 3.
1 over square root 3.
So this was 1 over root, right, 1 over square root 3 before it got rationalized, okay? So I would go to my angles. I would figure out which one is opposite 1 and adjacent to root 3, which is 30 degrees. This time I want it where it's positive. Where's tangent positive?
First and third.
Good. First, which means 30 is my answer. And third, which means I do 180 plus 30. And 210 is the other one. Yeah.
How do you unrationalize these?
Just move it to the bottom. Like the square root that was in the top goes to the bottom, basically. So like if it was, you're dividing by root 3 is really what you're doing. It's reversing it. Does that make sense? Yeah.
Why do we have to define?
Why do you have to what?
Why do we have to find which quadrant it's positive of?
Because there's more than one answer there.
But were we finding the negative for all of the other ones?
That's because all those other values were negative. Look at the question. Right? They were negative to begin with. Now it's positive. 17 was plus and minus. That's why there was 4 of them.
So for 17, it's all 4 of them.
Right? Because it's plus and minus. So it'd be the 2 quadrants where it's negative and the 2 quadrants where it's positive. Yep.
How did you get the 30 again?
Because if you go to your triangle, right? I reversed it to figure out where it was rationalized. It would have been 1 over root 3. So then I go to my triangle, and opposite the 1 is the 30 degrees.
Oh, so 30 degrees on the right too?
Yep, because it's first quadrant. That's where it's positive.
Oh, okay.
Yep.
Wait, why did you rationalize the square root of 3 over 30?
Because if you look at these values, think about these two triangles. Neither of them have a side length of 3. They have a root 3, but they don't have a 3. And that's what tells you it was rationalized. Mm-hmm.
Are we always going to use those two triangles? And
Mhm.
is there any more triangles we need to?
Nope, but we're going to figure out how to do this with a calculator now. So without a calculator, it's those two triangles and only those two triangles. But obviously with a calculator, that's what is complete. It's not completely different, but there's no restriction on it. Questions? All right, so we're going to add the last 3 questions of homework from last night onto tonight's homework. It's not on there yet, so if you already opened it, you might want to screenshot the last 3 questions of last night's homework and add it to tonight's, but it will be part of it, okay? All right, then we get into 5-4, solving right triangles. Some of this stuff is completely review. We've done it, you've done it in, you did it in geometry. And then at the end, we get into all the new stuff with the calculator. So in the beginning, we are again reviewing SOHCAHTOA. The difference now is that these triangles are not going to be special triangles. These can have any value in their angles. They have to be right triangles, but they don't have to be 30, 60, 90, or 45, 45, 90 triangles. So if you remember like the word problems from geometry, somebody's looking up at a tree, you set up a triangle, you solve for a side, that's what this stuff is, okay? So you're going to label your triangle, you're going to use the capital letters as the angles and the lowercase as the sides. You're going to set up your equations using one of those 3, depending on what you have. And then you're going to solve for all the missing sides and all the missing angles. So if the directions say solve the triangle, it means find all the missing sides and all the missing angles. And they will look something like this. Solve the right triangle, round your answers to the nearest tenth. So if I'm given in the instructions that angle A is 31.67 degrees, side A is opposite angle A, so this would be 35.9. That's a length. I need to find everything that's missing. I already know that C is the right angle. So I need angle B, I need side B, and I need side C. Easiest thing to find is your angle, okay? Because you can either add the 2 there and subtract it from 180, or do 90 minus 31.67. Yes, it's opposite where the letter is. So the B, this is B, and this is C. So 90 minus 31.67 gives me 58.33 degrees. That's angle B. And then to find the sides, I'm going to stick with the information they originally gave me. So I'm going to use angle A. And then one at a time, I'm going to solve them. So I'm going to pair it, God bless you, with the side they gave you and the side you're looking for. Depending on where they are located will tell you if you're using sine, cosine, or tangent. So in respect to 31.67, where is the 35.9? Opposite. Where's the B? Adjacent. Which trig function is opposite and adjacent? Tangent. So I'm going to say tangent of the angle that I have.
How do you know it's that angle?
Because I want to use the one they gave me. If you find the other one wrong, now everything's wrong after it. Yeah, you could use either one if they're both right. But I would stick with the information that they give you. So the tan of 31.67 would equal opposite, which is 35.9, over adjacent, which is B. And then I want to solve for B. So I'd multiply both sides by B. I'd get B times the tangent of 31.67 equals 35.9. Yeah?
Why not find C first?
It doesn't matter what order you do it in. And then divide both sides by the tangent of 31.67.
Get the short one like that.
No, the shortcut is if the variable's in the bottom, you divide this by that. And you certainly don't need to work it all out. I would at least show your setup so that if you do something wrong, I can give you partial credit.
And your calculator?
Yeah, but you have to be in degrees here. And every time you reset your calculator, like I'm going to make you do, it puts it back into radians. So you have to remember to change it to degrees. For the graphing utility, you're going to go mode. Mode is here, next to the second. Record. You go mode, and then on the third line, you switch it from radians to degrees. Every time you hit second plus 712, it's going to I thought I was on the board. So after you do that, and you do 35 divided by the tangent of 31.67b, should be 58.19 or 58.2. Did you find it, Xavier?
Yeah, I got it.
All right, and then I want to find I want to find C. Now, technically, I have two options. I can use the Pythagorean theorem, okay? I have three options. I can use the Pythagorean theorem. I can use B, what I just found with C, and that would be cosine. But both of those are using a rounded amount. So I want to avoid both of those, and I want to stick with the information they originally gave me, which means I'm going to use the 31.67, the opposite side, and the hypotenuse, and that's sine. So sine of 31.67 equals 35.9 over C. And when the variable is in the bottom, I divide what's over it by the other side. So 35.9 divided by the sine of 31.67. And C is 68.37 or 68.4. Now, if I had extra time, I would check those using the Pythagorean theorem. I would see if 35.9 squared plus 58.2 squared equals 68.4 squared. And it's not going to be exact because we rounded it, but it should be pretty close. This gives me 4676.05. And this gives me 4678.56. It's never going to be equal because we rounded it, but it should be close.
How did we input the sine 31.6?
This divided by that. All right, we're going to do it again. Again, it says solve, so I'm finding anything that's missing. So I have angle C is already marked as the right angle. Angle B is 47.8 degrees. And side C, which is opposite the capital C, in this case, it's your hypotenuse, 89.6. So I need angle A,
42.2.
I need side A, and I need side B. So for angle A, I'm going to do 90 minus 47.8.
42.2.
Thank you. And then I want to find A and I want to find B. And it doesn't matter which order you do this in. If I want to find A first, A is adjacent to the 47.8. And the other piece of information I have is the hypotenuse. So adjacent and hypotenuse is cosine. Cosine of 47.8 equals adjacent, which is A, over hypotenuse, which is 89.6. To solve when the variable's on the top, we just have to multiply by the denominator. So 89.6. Be careful how you type that in your calculator. You can't put it back here without putting a parentheses at the end of the 8. So I just write it the other way. I do 89.6 times the cosine of 47.8. And you get A is 60.18 or 60.2. And then to find B, now B is opposite the 47.8. I still have the hypotenuse, so now it's sine. Sine of 47.8 equals opposite over hypotenuse. The variable's in the top, so I just multiply by what's in the bottom. 89.6 times the sine of 47.8. And B is 66.37 or 66.4. And if I want to check, I would do A, which is 60.2 squared, plus B, 66.4 squared, and see if it equals 89.6 squared. Again, not going to be exact, but it should be close.
When do we know to multiply and when do we know to divide?
If the variable's in the top, you multiply. If the variable's in the bottom, you divide. So again, not exact, but close. Questions on that one? All right, so most likely your test will be something like this where the diagram is not there and you've got to draw it out. But you want to make sure you read the directions. In the top it says, solve the right triangle given C is the right angle. So like if you put the wrong, obviously if you put the wrong angle as the right angle, it's going to be a problem. You want to make sure you read it. For 3, it says A is 61 degrees. It says side B, 39.2. So I need angle B, I need side A, and I need side C. So if I did 90 minus the 61, I get 29 for angle B. And then I want to stick with the information that they originally gave me. So if I'm trying to find A is opposite the 61 and the 39.2 is adjacent, which means tangent. So the tangent of 61 is equal to A over 39.2. And because the value's in the bottom and the variable's in the top, we just have to multiply. And 39.2 times the tangent of 61 gives me 70.71. So 70.7 is my A. It would be in centimeters if it wanted the unit. And then side C, I would use again what they originally gave me. So angle 61, C is the hypotenuse, 39.2 is adjacent. So I use cosine. Cosine 61 equals adjacent, 39.2 over hypotenuse. When the value's in the top, I divide the value by the cosine of the angle. So in the calculator, I'm going to do 39.2 divided by the cosine of 61. God bless you. And I get C is 80.85, so that's going to be 80.9. And again, you can use the Pythagorean theorem with A and C and B to check the sides. It's not going to be perfect, but it should be close. Yep.
I got 80.84.
You did 39.2 divided by the cosine of 61. You should get 80.8564. Retype it in. 39.2 divided by cosine of 61. Okay, then the second one, so it gives you angle B is 46, which means angle A would be 44 degrees because I'd subtract it from 90. I'm missing side A and I'm missing side B. If I go with A first, that's opposite and I'm given the hypotenuse, which means, not opposite, adjacent, which means cosine of 46 equals A over 29.7, and I'd multiply 29.7 times the cosine of 46. And I get 20.63. And then for B, that one's opposite, so this would be sine. Sine of 46 equals opposite over hypotenuse. And then we multiply. And I get B equals 21.36 or 21.4. Questions on those? Yeah.
How do you know which one's that, when you have
Depends on what side you're looking for and what you're given. So if my angle is here and I want to find A is adjacent. And I'm given here, that's hypotenuse. Adjacent and hypotenuse is cosine. If I want to find B, now it's opposite and I'm given hypotenuse. So that's sine. So it depends on what you're given and what you're looking for. Xavier. All right, these are what happens if you're given the side lengths and no angles. So it says solve the right triangle, given C is the right angle, round answers to the nearest tenth. Same exact set of instructions. But if I am to label this triangle, so C is my right angle, this time what I'm given is side A is 958, side B is 489. I'm missing side C, and then obviously I'm missing the two angles. So I need angle A, I need angle B, and I need side C. Start with side C. How would I find it?
90.
Nope. You can't do the trig function of the 90 though. Pythagorean theorem. You're given two side lengths, right? You want to find the third. So I would do 489 squared plus 958 squared equals C squared. 489 squared. 958 squared. So I can just add those. I could do 489 squared plus 958 squared, and I'd get 1156885. But I don't have to write them out separately. That literally could have all been one step. And then square root that answer. And I get C is 1075.58, so 1075.6. It's above your x squared, so like diagonal from 7. You're welcome. Now I would not use C again because that is a rounded value. I'm going to stick with the values that they originally gave me because those are 1 whole numbers, 2, they were not rounded at all. Yeah.
Is it not plus or minus?
No, because it's a side length.
Oh, so it can't be negative.
Correct. Technically, yes, plus and minus, but we're talking about a triangle, it can't have a negative side. It's not in my unit circle, so it's not moving around. To find the other ones, let's say I want to find angle A, I will use the two sides that are given and in respect to angle A, 958 is opposite and 489 is adjacent, and that trig function is tangent. So I would say the tangent of angle A equals 958 over 489. And when you are given the ratio and you're looking for the angle, you use the -1 button. So the button on top of tangent says tan -1. And I do tan -1 of 958 over 489. Second tangent, 958 divided by 489. And I get angle A is 62.95. This is going to bump. This is going to bump, so angle A is 63.0 degrees.
Are you rounding it?
You're rounding to the nearest tenth, but it was a 9.5, so the 5 bumps up the 9. Yep.
Like right there, since it's rounded, you do the math, and the other one for just the 27.
You could just do 27. So to get B, you actually could do two things. To get angle B, you could now B would be opposite would be the 489 and adjacent would be the 958. So I could see that the tan of B is 489 over 958, and I would do tan -1 of that. 489 divided by 958, and I get angle B is 27.04, which is 27.0. So faster than that would have been to take your 63.0 and subtract it from 90. You could do either one.
Even if it's rounded, you can do it?
Yeah. What will happen on these, so these will probably not be on your multiple choice part because depending on where you round it, it does have that effect. You like we would probably give you within a tenth, depending on what it is. Yeah. All right, we're going to do 6 to start tomorrow, and then we're going to finish out the notes. When you go to your homework, I added this. This is the 3 questions that were from the end of yesterday that we started with today. So I put the screenshot on there, but you might already have it obviously on the PDF from yesterday. This needs to get added in. So this is what we started with. Those 3 would be the ones where you have to figure out what quadrant and which angle it is. And then you can do everything except for, well, we didn't get to any of these. The beginning ones that say from 5-3, like those we didn't get to yet. All of these we did. Note that some of this, like this one, is in degree minute second notation. So the first thing I would do there is convert it. Make it easier on yourself so you don't have to type it in every time. You could also type it in every time like that, but you could also just convert it.
Are we using a calculator?
All of this is calculated. Well, not the first ones from like yesterday's stuff. The 93, 90, whatever those from yesterday's stuff, no calculator. These calculator.
So will there be 2 parts?
Yep. Yeah.
So is it due tomorrow morning?
No, it's due Friday.
Oh.
Yeah.